Welcome to yet another exciting educational video brought to you by Upvision Concepts Academy. So today we are seeing IGCSE Physics. Topic for discussion today is friction, drag, and thermal velocity. By way of objective, by the end of this lesson, you should be able to, number one, describe friction and drag as forces that oppose motion. Number two, explain the difference between friction, solid surfaces, and drag, and surfaces such as air or water. Number three, identify how friction and drag affect moving objects. Number four, explain step by step how thermal velocity is reached. Number five, draw force diagram showing weight, drag, and friction. Number six, explain how changing shape or surfaces affect drag and friction. And finally, you should be able to answer exam questions involving falling objects, vehicles, and streamlined shape. So sit tight and enjoy the video. It promises to be exciting. Please subscribe if you're not subscribed to our channel, and engage us in the comment section. Share with friends so that they'll be aware of what we are doing here. So we dive in. So what is friction? What is friction? So friction is a force that opposes motion between two solid surfaces in contact. Friction is a force that opposes motion between two surfaces in contact. So if a surface is gliding over another surface and they are in contact, let's say this is A, body A and body B, and A is moving this way, B is moving this way. Now there's a force that tries to oppose the motion in between these two forces. So if we say friction is a force, the first thing here is friction is a force, right? So what comes to your mind is that it's measured in newtons. That's the units of friction. But that force, what does it do? It opposes the motion between two solid surfaces in contact. So examples of friction include shoes on the floor. So your shoe on the floor, if you are wearing them or staying alone, is being opposed by friction. The shoes and the floor are two surfaces in contact, but there is a friction opposing them from moving opposite direction. So another example is tires on the road. Tires on the road. So if the tire is moving on the road, maybe driven by a vehicle, you see that there is a force that tries to oppose the tire from moving forward. Between the tires and the road, the force exists. That force is known as the frictional force. And thirdly, my examples, I will say brakes on the bike. Brakes on the bike. So if you apply the brakes on the bicycle, there is a frictional force that will try to oppose that action. So friction always acts in opposite direction to movement. So if movement is going this way, this movement, friction will be going the other way as friction. So friction always acts in opposite direction to movement. Okay, and even as friction is happening, the byproduct of friction is heat. So friction produces heat and eventually slows the object down. So it can be useful when you are walking. So it can be useful when you are walking. When you are walking, there's a grip you feel. That grip you feel is the friction. Or unwanted energy losses in machines. So there are two things I'm talking about here. I'm saying that one, it is useful because it can be used to cause a grip for you. And secondly, on the other hand, on the flip side, you can have losses in engines because of the heat that is dissipated while you have friction. So drag, air resistance, and water resistance. You know, we talk about friction, and friction is a force that opposes motion between two solid bodies. Now, we'll leave solid bodies and talk about maybe liquid bodies or water body or air bodies. So in air, or drag is a friction that acts when an object moves through a fluid, air or water. So I have air going this way, maybe another air going this way. So this is the direction of this first air and direction of second air. So in between the two of them, there's what they call drag. So drag is actually a friction, kind of friction, you understand, that now acts when an object moves through a fluid, air or water. Okay, so if that object is moving through a fluid or air, water, we call drag. So in air, we call it air resistance. In air, it is called air resistance. Okay, and in water, it is called water resistance. So these are the two things that can cause a drag. Okay, so drag forces increases as speed increases. So as the speed of either air or water, the medium where the drag is happening, as the speed is increasing, then drag force also increase. Also, surface area increases when drag force increases, and drag force increases as the fluid becomes thicker. When I say thicker, that's the viscosity is high. Okay, so let me just, by way of put on the board, I say that drag force increases. You can be asked this in your exams, increases as the following happens. Number one. So drag force increases as the speed increases. So speed increase also bring about increase in drag force. Well, then number two, drag force increases as the surface area increases. Then number three, drag force increases as the fluid becomes thicker. The fluid becomes thicker. So this thickness has to do with what they call viscosity. We'll talk about it later. Viscosity. There's no U here. Viscosity. Okay. So we look at how friction and drag change the motion of objects. So both drag and friction, the difference between drag and friction again, drag is for air and fluid, and friction is for solid. So but both of them have opposing of motion of substances that are having relative motion. For the case of friction, it is two solid objects, and for the case of drag, it is the solid inside either the fluid or the air. You understand? So but both of them oppose motion. So these are the similarities. When they say similarities of these two here. So both of them also reduce acceleration. Both of them slow objects down. And both of them convert kinetic energy to heat. Okay. So this is what friction and drag does to motion of objects. Okay, so terminal velocity happens only when an object is moving through fluid. So that there's a velocity that is called terminal velocity, and it only happens inside a fluid or air. Understand? So a falling object goes through 3 stages. So when an object is falling, it goes through 3 stages. The first stage, stage one, start of fall. Stage two, speed building up. So when you start fall, the next thing is speed is building up. Speed building up. And stage three, you have terminal velocity is reached. Stage three, terminal velocity is reached. So if a body is falling from the sky, falling from up, there is start of fall, there is the speed building up, and there is terminal velocity being reached. Now, what are the things that happen in these stages? When the body starts falling, first thing that we observe is that the weight is much larger than air resistance. Weight is much larger than air resistance. That's the first thing that we notice. Second thing is that resultant force is downward. Yes, resultant force is downward. Resultant force is downward. What does that mean? It means that there is a force greater pulling it down. This is the body now falling. So there's a force pulling it down. That resultant force is greater than the one that will sustain it. That is why the thing is falling down. If the force going up was equal to this one, the body will not fall. Body will be stuck in the air. So, start of fall, the resultant force is downward. Then, third thing that we notice is that the object will accelerate. The object will accelerate. All this happens at the start of fall. Now, when the stage 2 is reached, when the speed is building up, the body is accelerating, right? So when the speed is building up, we notice that air resistance increases because speed increases. You see? Air resistance increases because speed increases. What is happening here? As the speed is increasing, air resistance will try to increase. Why? Because air resistance is wanting to keep the body at a constant speed, but the speed is increasing. So the air resistance is like the drag, the opposing force that is trying to stop that body or trying to slow down that body from increasing. Now, if this air resistance goes more than it is because the speed is increasing, it will try to balance that speed so that that body will not increase in speed. But another thing is now notice why air resistance is increasing. The resultant force will decrease. Resultant force will decrease. Resultant force will decrease. It's decreasing. Why? Because the air resistance is catching up with the speed. Once that air resistance is reducing the speed, resultant force will now decrease. Remember, the resultant force was actually going downwards, and it will be higher in the first stage. But when it comes to this stage, the resultant force will slow down. Why? Because the air resistance has decreased. And if the force is decreasing, the acceleration will also decrease. You know, force and acceleration are related in international proportionality. Acceleration will decrease. So note all these things that happen in these stages. But a time will come when terminal velocity is reached. What happens here? First of all, air resistance becomes equal to weight. Weight is that force that is bringing it down. Air resistance is the one that is taking it up. So air resistance is equal to weight. Is equal to weight. Ha ha ha. What happens here? Then resultant force is equals to 0. Acceleration is equals to 0. And the object will continue to fall at constant speed. Object falls at constant speed. Speed is constant. So this is the journey of how terminal velocity is reached. It starts from fall. it goes to speed building up and terminal velocity being reached. Note the things that happen, because they can ask you at the start of 4 what happens. They will put all this in the options and they will put one of these. They will say which of these is not seen at the start of 4. They will put this, put this, put this, they will put this. So if you know all the things that are seen at the start of 4, you're going to do that some of them are not, these ones are not there. So know what is synonymous to a particular stage. Start of 4, first of all, the weight is much larger than the air resistance. So when the body is released to start falling, the weight is larger than the air resistance. But as it's going down, as it's going down, the object will begin to accelerate, right? That's start of 4. So 3 things: weight is larger than the air resistance, resultant force is going downwards, object will accelerate. Then, as it's going to build up speed, air resistance increases because speed is increasing. That air resistance is trying to reduce that speed. A time will come when the resultant force will begin to decrease because the speed, air resistance has increased, and acceleration will also decrease. But terminal velocity is now reached when air resistance is equal to the weight. At terminal velocity, again, resultant force is 0, acceleration is 0, and speed of the body is constant. Okay, so I have on the board, it says a 10 Newton force acts to the right on the block. Friction of 4 Newton acts to the left. Find the resultant. Find the resultant. So right force is equals to 10 Newton. Left force is equals to 4 Newton. Let me draw this as a diagram. So this is the body at rest, right? So there's a right force. This is the right force. So the right force is going this way. Right force is 10 Newton, going this way, pushing the body this way. And the left force is going this way, 4 Newton, pushing it this way. So this 4 Newton is not enough to cancel out this one. What happens is that this 4 Newton acting this way and it's acting this way. I can do an algebraic summation of this force. From your number line, anything going to the left is minus, so this is minus 4. Anything going to the right is plus, this is plus 10, right? So if I do this algebraic sum, minus 4 plus 10 will give me 6 Newton. So 6 Newton is the resultant, but because it's still plus, it's acting on the right. So the final answer is 6 Newton to the right. So I write it like this, 6 Newton to the right. So anytime you are doing vectorial analysis of a body and with forces acting, always use your Cartesian plane to guide you. Your Cartesian plane looks like this. From your Cartesian plane, this is the number line, right? Number line, this is 0 center. And this is, to the right is positive, to the left is negative. The same thing, if you won't have it in cardinal points, up is positive. So if the body is going up, if the force is acting up, this is positive. And the force is acting down, this is negative. You understand? So that's what I'm using here to analyze this. Okay, so a car engine provides a forward force of 3,000 Newton. Drag and friction total is 2,600. Find the resultant force and describe the motion. Okay, so resultant actually is the summation or the right summation of those two forces in the direction. You know, force is directional, right? Okay, so resultant actually, if the car engine provides a forward force, so this is the car engine. Wow, so let me do the car like this. Okay, so the car is moving this way. So the forward motion is provided by a 3,000 Newton thrust. And the drag and the friction acting the other way is 2,600. I told you that this is the left side of the Cartesian plane is negative. So, and this one is positive, right? So I say minus 2,600 plus 3,000. The summation of these two will give me 400 Newton. So this 400 Newton is acting, because it's positive, it's acting forward. So it is 400 Newton forward, that's the direction, forward. And The car is accelerating forward. The car is accelerating forward. What else can I infer? So if the drag increases until it reaches 300, this drag here, if it increases until it reaches 3000, that means the resultant will be 0 and car moves at a constant speed. So the implication of drag and forward force becoming equal is that there will be no resultant force. There will be no force, propelling it forward. It's just that the car will just be moving at constant speed. Speed does not affect force. Only acceleration does. If there's no resultant force coming, the acceleration will not be there. But if there's a resultant force coming, the car will be accelerating. Okay, let's do one more example. Okay, so this question is actually an IGCSE 2017 model question. This question came out in 2017, so that's where I got this one from, 2017. So the question related to this topic, it says, a skydiver reaches terminal velocity. Skydivers are those guys that jumps off from a plane with a parachute. So a skydiver reaches terminal velocity. Explain why this happens. Okay, remember I told you about the 3 stages of fall. You have stage 1, stage 2, stage 3. Remember, I said stage 1 is start of fall, stage 2 is speed is building up, and stage 3 is terminal velocity is reached. That's what they want you to explain here. Okay, so we're going to be applying it while trying to explain it. So it says, let's explain what happened. So first thing I say, as the diver, this is the answer. As the skydiver speeds up, as it speeds up, air resistance increases until it becomes equal to the weight. Air resistance increases until it becomes equal to the weight. So when this happens, when this is attained, when the air resistance becomes equal to the weight, what happens is that there will be no resultant force. Acceleration will become 0. You understand? So here, the force becomes balanced. So the force becomes balanced. Why? Because no resultant force. No resultant force. The air resistance going up, and the weight going down becomes equal. Yeah? So the force becomes balanced. So no acceleration. So no acceleration. Please remember all these things. They give you the mark. So no acceleration because acceleration becomes 0. Then the diver will now continue at a constant speed. The diver will continue at a constant speed. That's what happens. At a constant speed. Okay, that's what happens. So in marking this, you see how I mentioned it. The first thing, you are mentioning air resistance. You're mentioning air resistance increasing. You get mark from there. You are mentioning balancing forces. The force become balanced. You get mark from there. And speed remain constant. Continue at constant speed. You get mark from there. So this topic, you need to understand those stages of fall, understand what friction and what drag is, why friction is forces opposing two solid surfaces. Drag is actually air resistance, in a or liquid resistance with an object inside. You understand? So I hope this video has been helpful for you. I'd like to thank you for viewing.